there's some very valuable lessons from this going forward to the rest of the world that may be looking at some of these issues in and around combustible construction. There's going to be a question and answer period at the end, and we can get to that. And I'm looking forward to that as being a good, frank opportunity to be able to discuss some of these challenges and perhaps come to some recommended ways to proceed with this. So without further ado, I'll give you a little bit of an outline here. I need to give you a little bit of a background about the Canadian Fire Service for some of you who may not be aware and familiar with this. It's very important to understand why the challenges are so unique to what we are dealing with. But I'm also going to give you a background about the Canadian experience with sustainable construction and the Canadian code system in general. Then we're going to get into what I call, or what the Canadian Association of Fire Chiefs is calling, the Readiness Gap, and how we are going to try and address the issues and challenges in that and the recommendations to go forward. So really first, it's important to have an understanding about the Canadian Fire Service and understand Canada and the nature of Canada. Second largest country in the world. We have 3,500 fire departments spread across the country. That's 10 provinces and 3 territories. We have 156,000 firefighters approximately, of which 85% of those are serving volunteer departments. Those are individuals that are paid on call or volunteers that serve in all of those locations and jurisdictions. We rely on municipal funding for everything that we do. There is no provincial funding or federal funding in the form of grants or support and what happens with regards to that. But also a key point that I want to stress, and it's a sour point a little bit with me as well, is that considering the size of the country, we actually only have 7 fire departments across the entire country that actually have a fire protection engineer or multiple fire protection engineers on staff in what we deal with. So again, that is part of the issue or problems that we deal with as well. And another final point, and one that we've been trying to deal with for well over a decade now, is that unlike the UK, unlike the United States or Australia, there is no national fire advisor. As in, there is no single federal department or agency or individual that looks at the federal level of what needs to be done. And in fact, the federal government even used to have a Dominion Fire Commissioner's Office, but that role over the past few decades has diminished to be where it is only, or was only then serving the federal government departments. And even of the last 10 years or so, the federal government devolved or dissolved that body and pushed the responsibility for fire protection engineering and fire life safety down to each of the federal departments. They had their own responsibilities for their own jurisdictions. So there is no national presence at all with regards to that, which is a huge challenge in trying to bring attention to issues. So when we take a look at the Canadian code challenges in wood frames, we need to go back and also take a look at where we are in Canada. For those of you who may not be aware, Canada, in a true compromise, did not go with the performance-based or an alternative design type of review. Instead, what we went with was what a truly Canadian concept, and that was what I call an objective-based codes process. And what that basically means is that every provision, the code remained prescriptive, but every single element within the codes, the building and the fire codes, links back to an objective within the fire code, building or fire code, which was intended to make it easier in the future for alternative solutions, in that they would only have to address the objectives and the functional statements in the code. In reality, that never happened. The reality is that building officials and fire officials in their municipalities were basically coached by their municipalities and their legal experts to basically say, if it's not written in the code, if you exercise judgment, you're assuming liability. And assuming liability is not something municipalities want. And so therefore, we really have resulted in still just a prescriptive-based code. So what is happening is that starting with the 2015 National Building Code and the 2020 National Building Code, the wood industry and others introduced additional prescriptive requirements into the code that in 2015 facilitated or enabled mid-rise construction to increase combustible construction out of stick frame to go from 4 stories now to 6 stories. And what is happening with the soon-to-be-released 2020 National Building Code, allowing combustible construction to go up to 12 stories in height using encapsulated mass timber. So huge issues and challenges. And really, a lot of it goes back to a lack of the fire and life safety professionals that I believe we have throughout our country. Now, experiences that we had with going to mid-rise and encapsulated mass timber identified several problems and challenges we have with the code process here in Canada. And I think somewhat maybe also in the United States. The code process basically allows industry, in this case, those with a vested interest, the wood industry in particular, to bring new technologies to market that would, they state, stimulate the economy and create major investment returns. And it was in their interest to forward these changes. But one of the questions that doesn't get asked is in their cost benefit analysis is they don't have to address the aspect is, are we actually ready for this innovation? That is a separate piece that the emergency response and safety perspectives have to become an address. And unfortunately, that is not picked up in the code development process. The analogy I look at this is that industry, and in this case, builders that would build with this type of technology, reap all of the benefits, but the liabilities for the introduction of this technology rest on the municipal fire services and the municipalities. And there's no way for them to collect or bring in from those benefits. The other intended consequences of this whole process is that the industry and their subject matter experts that they hire can actually skew the process because they can put the time and effort into these detailed studies and analyses, while the fire service, because we are so dispersed and disjointed, are forever challenged on our abilities to be able to present good science and to be investing in the amount of money it takes to put forward some of these code changes. So essentially, we do not have the time, resources, and capacity to generate research-grade evidence. And that goes back to, again, it's individual municipalities that run the fire services in their country, and they don't invest in time, put forward code change proposals. And in fact, they're individuals that they allow to participate in the code development process are doing so on their own time, away from work as volunteers for all intents and purposes. So it creates some huge challenges. So really, when you take a look at it, who directly benefits from those code processes changes it's those that are proposing the changes, but the risks still remain borne by the municipalities, and there's no means of checking and ensuring that this is done. And so this is where we get to a lot of the issue in and around readiness. Who's looking at whether we have the resources, knowledge, and training and capacity in our fire services to do a lot of this work? We don't reap the change from the code change proposal, the benefits. And so we are left in many cases trying to pick up the pieces. And unfortunately, we faced with major issues after the fact of trying to address these changes after major significant fires. We are left to try and answer those questions. So to the point here is that in mid-rise changes were introduced to our National Building Code in 2015, and these were the changes that allowed us to go to 6 stories of combustible construction, provided that the properties were sprinkled. A lot of the testing was based on several compartment fires that were looked at, and they extrapolated from those compartment fires the ability to do some large-scale tests. So when this was first put forward as change proposals starting in around 2009, 2010, the Canadian Fire Services, National Fire Protection Association, the Provincial Fire Chiefs Association all raised a number of issues and concerns with regards to how this was going. We actually also looked at the UK experience, what had happened with mid-rise construction, and some of the reports, such as the TF 2000 reports, some of the London experience reports of what they had with regards to as-built constructions and challenges. And we attempted to put forward a lot of those issues and challenges. We identified those in some of our journals and publications, such as our Canadian Association of Fire Chiefs magazine that identified 6-story wood frame buildings in British Columbia. The title there and was What Happens When Politics and Jobs Outweigh Fire Safety. We raised a lot of issues and concerns, again, about the lack of research, the lack of addressing the concerns in around construction fire safety, and the general lack of education and follow-on training given to the fire services. And it's important to remember what those issues and challenges that we raised were, because you're going to hear the same thing in 2020. And the overall theme for a lot of the messaging, and I presented at the IFE International Conference in 2010 on this subject, and the theme basically that we had, or I had in the presentation, was just because the building code says you can does not mean you should. Identifying that there needed to be a better connection between our building codes and what the capabilities and understanding of the capabilities were of the local fire services. Now, flash forward to 2020, and what we are now facing with is, again, the wood industry and others in Canada presented a detailed presentation going forward based on 2 National Research Council of Canada compartment burn studies that suggested that it is okay to go now from 6 to 12 stories of combustible construction. But we would now change the definition of combustible construction to be that of encapsulated mass timber. And encapsulated mass timber was basically a new definition or a term where we would take CLT floors, walls, and columns, and provided that we protected them with 2 layers of gypsum board, we would be able to go forward with this. And the intention was to look at going to 6 to 12 stories in height, but as well allow in individual compartments up to 30% of that compartment to have exposed mass timber, exposed timber elements such as floors, ceilings, or wall components that were exposed timber. A lot of this was based off of 2 demonstration projects, one that went forward, the Brock Commons building in the University of British Columbia in Vancouver, and one that was occurring in Quebec City, in Quebec. And a lot of this was, again, going forward based on the requirements that this could be done based on these 2 studies. Now, they put these changes forward and codified them into the National Building Code because in their own statements, they said that it is because the building officials were reluctant to go forward and follow an equivalent-based design solution process or an acceptable solution process. So therefore, based on these demonstration projects and some design manuals, they introduced and put this into the codes. The result of which is that when the code is published later in 2021, it will allow CLT buildings to be built in any community in Canada, regardless of what the capabilities of those fire services communities are, and not having to go an alternative design approach. Major concerns, again, were identified, and unlike at least in the 2015 issue, where fire services members were involved in some of the working group, the changes were presented for public consultation, which was when the first time that the fire services became aware of these changes. So, well, how does this translate with regards to our code process? Well, in our opinion, encapsulated mass timber construction may actually be very good or beneficial to society. It may be good for the environment. It may be good for economy. It may produce buildings that are cheaper to construct. But the fire service is not in a position to judge the science, economics, or relative impacts. But what we are able to judge is our ability to be able to respond. So we do not want to be in a position to learn about these structures at 2 o'clock in the morning when they're spewing smoke. That is when we do not want to be learning on the job. Instead, we've identified, and we'll be talking about a little later on in this report, issues or gaps that we believe must be addressed now or invested in applied research to improve what we can do. And that many of these code changes that we see in this case in point is that we need to be prepared preemptively for this. We need to be engaged up front to be addressing these so that we can better be prepared to introduce this innovation. However, time and time again, we saw this with 2015 mid-rise, we're seeing with 2020, and we will likely see this with future changes unless we get a chance to express to those involved in the code development the value that the fire services can bring by being participatory up front in this whole development process. Now, I will say, as a fire protection engineer, my personal views on this subject is I do believe that encapsulated mass timber can be done safely and properly. And I do that based on my experience when, with Ottawa Fire Services, we actually looked and we're working for a potential trial project in the city of Ottawa. Ottawa Fire Services was well engaged as a department to do that because we could easily get an effective response force of over 60 plus firefighters to the downtown core where the building was proposed. We also had fire protection engineers on staff. We had a very robust safety division. We were very good on our education, and we were leading in the rollout of a fire dynamics curriculum worldwide to ensure that our firefighters were knowledgeable, capable, and understanding of fire dynamics technology. So therefore, in our view, we were prepared for this, and we were going to be participatory in the design, the building construction oversight, as well as the commissioning of the building. So we felt very comfortable. But as I stated earlier, codifying these now does not now mean that individual fire departments over the rest of Canada are so equally prepared. The other concern that I have as a fire protection engineer is that we've had no lived experience with any of these structures. We've never gone in now because the Brock Commons building and the Quebec City building have only just recently been completed, but we've had no lived experience with regards to those. We've not studied and looked at what happens proactively in a fire in those. We've not reviewed the construction practices. How well did they follow the recommended design guidelines? And what ended up happening is the National Research Council of Canada incorporated them into the code changes, basically 2 documents, directives or explanatory guides became the foundation for what became the code change proposals. Again, nothing linking this back to what the actual design practices were. And so there are still these huge gaps in our research and knowledge that we still need to fill. And I also am a strong proponent in believing that we need to benchmark and build upon what has happened in other jurisdictions. So let's take a look and see what has been happening in Europe. Let's see what's been happening with documents such as the International Building Code, the NFPA 5000 Building Code, the International Fire Code, and the NFPA 1 Fire Code. All of these need to be benchmarks. And unfortunately, we don't tend to do that very well in Canada. So one of the things that the Canadian Association of Fire Chiefs did is we tabled our own internal focus group to take a look at what were some of the fire science knowledge, information, training, resource, and readiness gaps. What were these? How are we going to fill those issues and concerns? And we did that by polling our membership, working with our building codes working group to be able to ensure that we had the consensus, what we believe is a consensus of the fire services, and we're able to speak on their behalf. And we've attempted to convey these with groups such as the National Research Council of Canada, Natural Resources Canada, and the Canadian Codes Centre. And I'll talk about our relative success later on. So one of the first areas we get into is the gaps in the science. So what we do know is that what was presented to us were basically 2 NRC testing studies that looked at compartment fires. But we've not seen any large-scale assembly tests, any tests that looked at structural components, other than just these 2 compartment tests. But from that, they were able to extrapolate that this would work well for 6 to 12 stories. We've not taken a look at what has been the structural behavior of some of these members. Is it really the same as a normal building? Post-fire, what happens? What are the impacts of the fire compartment on the fuel load? We do know from the compartment fire tests that having the exposed combustible elements do contribute to the compartment fire dynamics. But what does this mean now for those compartment fire dynamics, and what does it mean for the rest of the structure? What are the products of combustion? Is this a problem? We have major concerns with regards to firefighter health and safety. Does this change some of these? While these changes were put forward, there was no studies done on what were the proper water supply requirements needed for firefighting. In Canada, we follow the Fire Underwriter Survey water supply guidelines. There was no corresponding updates to address this new category or component of construction in order to determine what water supply requirements were needed for firefighting. CAFC was simply subsequently consulted and talked, and we provided our opinion with regards to this to Fire Underwriter Survey, and hopefully that will come out. But again, this was not done prior to the code changes. Again, what we don't know is what happens post-fire in a compartment fire here. What happens? How do you rehabilitate the building? Are we removing the sheetrock? What happens to water damaged elements? To the char and damaged elements of the CLT components? Are they planed down? Do they still have the same structural sufficiency? Do you have a requirement to build these up? What happens post-fire? We've just not seen that information yet. From an information and knowledge perspective, we mentioned again, what are the products of combustion? Water supplies for firefighting flows. How does this translate? And the fire dynamics in the individual compartment, how does this translate into the tactics that we need? Can we address this with single hoses? Do we need multiple streams? How do we remediate post-structure? What are the conditions that we should have for returning individuals to these rooms? Simple things is, do we have to evacuate the floor above, floor below? We know that the compartment fire dynamics change, but will this result in greater pressure? And in this method of construction, are we going to be pushing the smoke and gases out through the compartment into the floor and other areas? Because we just don't and have not any large-scale fire tests for this. Does it change our tactics? The number of firefighters that it takes for an effective response force? How many are those? There's been no studies or reviews with regards to this. You know, what is the impact of tenability on the rest of the apartment building, the rest of the floor? Should we be evacuating? Do we still use the defend in place approach with regards to tenants in the buildings? And then what do we want to know and need to learn to pre-plan these structures. So again, lack of lived experience, lack of applied research, and lack of studies taking a look at some of these elements. From a training and resource perspective, I think there's a hell of a lot we can do and to learn and to bring forward. We teach them about methods of construction. Well, EMTC is not one of those methods of construction that's taught in NFPA 220, nor is it taught in our fundamental firefighter skills. We train our firefighters to firefighters level 1, level 2 of NFPA 1001. But to be frank, we just don't get into training them on compartment fire dynamics. We also need to take a look at, how do our compartment fire tactics change? What are the nozzles that we need to attack such a fire? Are there thermal cameras should be equipped of every team that's entering the structure? Do we need those to find fires and void spaces? Again, firefighting force. What can we learn from those cities like Vancouver, Quebec City? We do know that at least in Vancouver, they were involved in rotating suppression crews through all phases of construction, which I believe is essential. So we need to be aware of that. We need to pre-plan these buildings during construction so we can see what the walls are composed of, where the walls are, what are the CLT bearing walls through those structures, what can we attack, or what can we not get through if we had to. And again, a shameless plug here is we need to be training all of our fire services personnel on the fundamentals of fire dynamics and fire compartment fire dynamics. Now, a little bit of a shameless plug here. I'd mentioned fire dynamics a few times, and that's because I believe that in many fire departments in North America, at least, this is a major missing piece. We have seen too many firefighter fatalities, near misses, where it showed a lack of fundamental understanding by fire suppression team members of compartment fire dynamics and what needs to happen. As a result of those issues and concerns, and led by a champion in his field, Peter McBride, who was our division chief of safety at the time, the Ottawa Fire Services was able to get a Canadian government grant of $1.3 million that was able to be parlayed into over $4 million of in-kind participation and support. And by partnering with over 60 agencies, we were able to develop a free, accessible, downloadable curriculum for any fire services that could follow to teach those fundamentals to their firefighters on fire dynamics. And this is a link here at firedynamicstraining.ca. So again, it's a free resource. We've made it available to the public, and we encourage all to take a look at that. And the intent was to bridge the gap in training and education of the fire services and fire dynamics and how this impacts tactics, trainings, etc. These were just some of the 60 partners that we had involved in this from, I believe, at least 12 countries. You may recognize some of the groups that were involved. And again, it could not have been done without the participation of all of these groups, as well as some sponsors that we had in this project. And so again, I would encourage you to take a look out, and if there's any feedback, please share it with me. We appreciate sharing that with the fire dynamics team. Other elements that again we have identified from the fire services perspective was again the overall lack of research and translation of that research into practical or applied knowledge. From a Canadian perspective, there does not appear to be a national strategy to address the EMTC research gaps, or even, to be quite frank, an acknowledgement that these gaps exist. We did see with the NFPA, the Research Foundation report from 2013, a very detailed review of the entire area of where these challenges, at least what they call tall wood buildings, exist, be it with systems level testing. Again, the emphasis worldwide seems to be just on individual fire compartments. No look at connections, penetrations, Again, to our point and concern that we had with regards to is how are these penetrations and the connections going to stand up against smoke penetration? There was identified or concerns initially on some CLT delamination, which I understand has been followed up with some additional studies. The need to study timber facades, because it goes hands in gloves with a lot of the CLT building, the EMTC buildings, is they want to showcase or highlight the use of timber. So there's a larger proportion of timber facades. And again, studies need to be taken a look at the protection of egress routes. So all this needs to be taken a look at. Other gaps that were identified by the CFC was, again, although there were changes made to the National Fire Code of Canada to address some of the risks during construction, there was still work needed to be done with regards to education of the fire services on understanding about encapsulation as stories rise and the water supplies were being brought up. So making sure the fire services were aware and were actually practicing this and were on site to review, test, and to ensure that those standpipe systems were functional. Construction site safety changes were good. That was great that those were introduced. But the problem, however, was, at least in the province of Ontario, is the province of Ontario, our largest province, was unique in that it does not have fire code provisions empowering the fire services to go in and address construction site safety. So it's a huge gap in Ontario. Other issues identified were maintenance requirements. Typically what happens is a building code tells you how the building is to be built. A fire code typically tells you then how to live with that building over the rest of its lifespan and how to maintain it. But some of the maintenance elements were addressed, but they were nowhere near the same level of provisions that were found in the IFC or the NFPA fire code. How were these being maintained over time? What were the concerns with regards to integrity? One of the provisions I liked in what I saw on the other codes was that there was an inventory maintained and a registry maintained of what was the degree of exposed wood in each of the suites. We don't want to have somebody coming in after market and removing encapsulation, thus changing what was approved in the code. These were gaps that were not found in the Canadian fire codes, and we believe need to be there. Now, going forward, what we've attempted to try and convey to the Canadian Fire Services, and we hope to convey to others that may be facing some of these questions, is that you need to listen to the fire services, because we're going to be the ones that inherit these structures. We're the ones that have inherited the risk and the liability in our municipalities for these. You need to look at addressing our systematic questions systematically and in an official manner up front, and this has not been done. We need to work with the fire services to develop and roll out system-wide training and information for encapsulated mass timber. This was missed with mid-rise. We need to do this for encapsulated mass timber. And we need to ensure that there's sufficient training resources, not just the knowledge, but its translation. And we need to understand when we do this research, such as the fire compartments, how does this impact our own fire dynamics? How does this impact then on our tactics, et cetera? And this research, ongoing research, needs to be funded from what we've suggested in Canada is a fire services innovation fund that is maintained and supported, that can be used then to direct applied research that would help bring the fire services along, that could then fund education programs. And another shameless plug here for the National Research Council of Canada and Ontario, and Ottawa specifically, is we need a national fire lab that is capable of looking at large-scale fire tests. We had one. It has been shut down because of environmental concerns for the past several years, and it has created a huge gap in our capacity to be able to meet some of these testing requirements. So going forward on the code processes, we need to make sure that the fire and emergency services are not just perceived as being another industry sector. It's not that we are different, but we inherit these structures. And unfortunately, we believe that we have a greater weight than just say the Wood Council or others who have a vested interest in seeing these things, a vested financial interest. It needs to be codified that when we look at cost benefit analyses or others, we need to take a look at the readiness of the safety sector. It needs to be a line entry item that any code change request must address and becomes a trigger point for ensuring the fire service is engaged. We've also been trying, since the establishment of the objective-based codes, the establishment of a firefighter safety objective in these codes. As I've mentioned before, any code change proposal has to be linked to an objective. Without an objective of a firefighter safety, we cannot introduce code changes that would be purported to protect firefighters. Floor performances, minimum floor performances, enhanced communication systems within structures to facilitate firefighting operations. There is no firefighter safety objective in the Canadian codes. They were lumped in as members of the public. And we've been trying to decouple and de-gauge this for close to 20 years. So we need the funds to train and educate the fire services for these changes and let those perceived cost benefits that are being identified, let them pony into this national fund to help pay for some of those changes up front. And then that could potentially even be used to support and fund the fire services participation in the code process, similar to the wood industry, concrete industry, steel industry, who have paid dedicated industry reps looking after their interest. And again, all of these things would only help us because, as we've stated before, we've still been trying for 14 years now to try and correct the issue of minimum floor performances in single-family dwellings. Again, this has been a difficult problem, and a lot of this is systemic problems that we found with the codes. Now, just a couple of quick thoughts on risk. Again, I've stated before, in the cost-benefit analysis, we need to take a look at a risk analysis component. And to me, the risk element specifically needs to take a look at what is our gap between our fire suppression capabilities, our training and education, current and future construction practices. That is what risk is to me. And as the more innovation is reduced daily and our firefighting capabilities are not keeping up, we are forever going to be outpaced by these new changes unless we invest in this. So again, any municipality needs to be looking at being engaged with their local fire services to be able to address whether they have that capability to address these types of structures. But also we need to be educating the fire services to be able to say, yeah, just because the code says that you can doesn't mean you should. And the fire services and the fire chiefs need to be emboldened and encouraged, supported to be able to say that they can do that in their municipalities. So from the CAFC's perspective, again, addressing this readiness gap, we have to recognize that in Canada and worldwide, that not all fire services are created equal. You need to address the readiness capability of the local fire brigade or municipal fire service. Are they capable? Can they have it? What needs to bring them along to be able to help them? You need to take a look at the training and education of its members, the equipment, resources to address these risks. And all of the costs associated for the upgrade in these capacities should be funded from the benefits of the project. And this, I've also stated, needs a national investment into applied research and education to bring the fire services along. The next challenges, well, we're already seeing it. We've already been identified. The CAFC has been approached by the by Natural Resources Canada to actively participate in an advisory body for them as they look at the next stages. Those next stages are, they are looking at several more compartment burns that will then be looking at increasing the height above 12 stories, as well as looking to increase the percentage of exposed spaces, of exposed CLT or other exposed wood faces within these compartments. So not only have they not even rested on the publication of the current codes, they're already seeking to go forward and demand more. We also know and are facing with the code challenges, the increasing demands for energy efficiencies in tall buildings and large buildings. We're having huge challenges with regards to in-building radio coverage. So again, we need to take a look at impact and research on that. And we also are knowing and hearing, of course, of stored energy systems coming into play, where we will be having large battery banks, large battery banks being in place in buildings to take advantage of off-peak energy storage issues. And there's huge firefighting challenges for those, not only just in those buildings, but also as these systems are going to be broadened and even put into single-family dwellings. So all of these are challenges, but the fire services need to be engaged up front in the code process. We need to be heard, and we need to be training to be ready for these challenges. So really, in conclusion, when we take a look at encapsulated mass timber, we don't want to be seen as being impediments to the advancements of what are potentially good benefits for society, but there needs to be a further engagement with the fire services on all of these pieces. The fire services are indeed interested in innovation. We do see this as being an opportunity for industry moving forward. And we need to bring them along early, meaningfully, and safely. And the only way, as we say, is doing that upfront. We can be good partners and friends with these changes. And again, another plug here for IFE. It is an absolutely important framework and a format for us to be able to facilitate some of these discussions, because we can bring the decision makers together and you can hear these issues and concerns and hopefully convey those when you're involved in decision makings or doing risk assessments in your communities. So again, I thank you for your patience in waiting for me. I will turn it over now to the panel. We can have some questions. I'm more than willing to do any follow-up questions if anybody has any. I'll stop sharing the presentation now and we can switch over to a format there. Thank you.
All right, thank you, Sean. Thank you very much. That was a really insightful presentation. We've already had a number of questions submitted before the meeting, but if you do have any questions, then you can add them into the meeting chat and we'll try and cover those. I'm conscious, Sean, that you've just spoken for an hour, so I thought it might just be helpful to talk around some of the different types of combustible structures and also some of the national operational guidance. So in terms of national operational guidance, that's for the fire service. We call them NOGs. And there are NOGs for various different issues that the fire service might encounter, in that regard, we have two different NOGs in this country. We've got one for SIP panels and one for lumped together traditional and lightweight timber frame construction. We don't actually have one for CLT, which is quite interesting, I think. So SIP panels is where we have chipboard and some insulation and then another layer of chipboard, and that is the structure. And then timber frame is what I think Sean knows as stick construction, which is, you know, pieces of, tends to be softwood timber, constructed only to a certain number of floors, because after that, structurally, it doesn't stand up to more than I think it's 6 floors. But with CLT, we're into a whole new ball game. So CLT is cross-laminated timber, and we have pieces of, generally in this country, softwood timber put across, and then another layer of pieces of timber are added on top of that, but at 90 degrees. So cross-laminated timber, hence the name. And by doing that, we actually glue together pieces of timber into one solid mass of timber, and we can then have, you know, solid floors and solid walls out of cross-laminated timber. So that's quite an interesting concept, because we're now able to build taller in combustible materials in timber. So I wonder, Sean, you know, can you talk about different issues, different factors that you might have to consider when you firefight in a combustible structure compared to a non-combustible structure? I mean, it probably sounds a very obvious question, but let's start at the basics.
Well, I think one of the fundamental concerns that we have and that we've identified is just in and around the compartment and the nature of the compartment. So when we start looking at the stick frame and the larger stick frame construction, the concern I have is that it is a lot easier for the fire to get out of that compartment into void spaces and affect the structural sufficiency of that building. So you cannot, in my opinion, use a defend in place tactic or messaging to individuals in those. So it fundamentally changes that. It changes the amount of water that you need to have. It raises huge concerns for me with regards to firefighter safety, floor performance, to be able to find some of the void spaces when we start dealing with stick frame. Now, CLT is a lot, as we said, it's solid. I have a lot different issues, concerns with regards to the tactics there. The concerns I have with CLT is just now you have the compartment itself is contributing to the fire because of the exposed CLT. So you're going to have, I believe, a much hotter fire. We don't know that, which is going to change issues, concerns about potentially how you approach or attack that fire. And we just don't know whether we should be looking at evacuating multiple floors or not. I lose a lot of sleep on a mid-rise stick frame fire. Those scare me to death. I've studied and looked at some of the reports coming from the UK about the quality of construction issues. All the testings we've had in Canada were basically done in the lab, where you could monitor and confirm that the gust plates were properly constructed, et cetera. But we don't know in the field that those practices, and cannot trust that the field that those practices were done. So the tactics are different, I believe. More water, faster. You need to be concerned about, I think, in evacuating the entire structure for a stick frame. But I believe we should be able to look at a defend in place approach, at least for the fire floor in mass timber.
Okay, so that's interesting. So still a combustible structure, but actually it sounds to me as if you have more concerns about lightweight timber frame than you perhaps do about CLT in terms of, you know, fire spread beyond the compartment. Yeah.
The overall structure. I have concerns that with a stick frame construction, you have a greater likelihood you're going to lose the entire structure if the fire gets into the void spaces. With CLT, because of the mass of the members involved, I think you have less of a concern. But I'd be definitely gravely concerned about the potential of losing the entire structure with a stick frame mid-rise.
Yeah, that's interesting, isn't it? Because when you watch a lightweight timber frame or a stick frame building get constructed, you can see all of the frame is put on, it is put up, and then the inside of rooms are clad with plasterboard, and then the outside of the building. But actually, once that fire is into that void where the structure is, then it's got free reign. There is nothing stopping it from going right through that whole structure, is there?
Correct. And that's why I think that the tactics you want to make sure if you're involved with mid-raise construction, that you have thermal imaging cameras, that the crews are familiar with the type of construction. And it's essential or imperative that there be proper fire stopping and that there be inspection even afterwards of the fire stopping methods to stop fires from getting into those void spaces.
Yeah, I think that's an interesting one because certainly in this country, we don't have, in a block of flats, that there's no legal right of access into an individual dwelling, for a single private home. So, it's very difficult then to ensure that plasterboard hasn't been breached, basically. People could do all sorts of things to breach that plasterboard, and I'm not sure that most people who live in those constructions understand the importance of that plasterboard, and also even from something like water damage. So it might not be conscious destruction, but actually just water damage, damaging that plasterboard then exposes that combustible frame to a potential fire in a compartment, and I'm not sure people understand that. I suppose another aspect that I was quite interested to hear you say was about sort of the, you're not too keen on defend in place, or sometimes we would call it stay put previously in timber frame, and that's what we do in blocks of flats, which is quite an interesting one, and the fire at Beechmere was a case in point, really. So you have a fire, and actually you've got sheltered housing where people perhaps are a little bit slower to leave, and we were very fortunate not to lose anyone in that fire, but we did lose the entire development, and I'm told it was a pretty close call. So that I can understand why you say you're sort of more concerned about that. You've got the ultimate, haven't you? You've got your perfect fire triangle once that fire gets into that frame, once into that void where the structure is, because you've got your air, you've got your ignition source, and you've got your fuel. And also it's unseen, I suppose. So from a firefighting perspective, how are you able to identify, a building might be timber, when you arrive on the scene? How does that sort of work?
Well, that I think really comes down to in a local fire services, they should be getting engaged in understanding what's happening and being construction in and around the in their neighborhoods. It goes to the whole requirement for pre-planning. Another thing that does happen in the NFPA fire code, there's a provision that allows a city or a jurisdiction to put a placard on a building to indicate the method of construction. So for instance, if it is lightweight construction, it could be identified with a placard. It's a Maltese cross, I believe, with an R, I believe it is. So identifies it as being that type of construction. But the key, in my opinion, is still an emphasis on the fire department pre-planning, getting out, seeing these structures in all stages. So during construction, to be able to be familiar with what is going on. The challenges that we have, however, in a large municipal department like Ottawa, is we rotated our fire crews around the city. So it couldn't always be guaranteed. So they just need to be aware that without a doubt, almost any building that we have that's up to 6 stories now in Ottawa and throughout most of the country is almost invariably built of stick frame, just because of how cheap it is to build. And by cheap, I mean in low cost, but also in quality of construction. So
it's quite interesting you say about that the issues with defending place, because there was a fire here in Brighton probably just under 2 years ago now, and I think that was 3-story block of flats, and the fire investigation report has recently come out, and it actually says that there was 17 minutes between the start of the fire and actually that whole building was untenable. And 17 minutes is actually a very short amount of time. I'm not quite sure, how many fire appliances could actually arrive there, or how much could be achieved in 17 minutes. I'm not sure that people, are planning on potentially that shorter time frame. That's that is a very different situation, isn't it?
yes, well, that to me also then goes to a bigger issue or challenge that I raise, and that is the municipal fire services being involved in the review of what is being built in their communities. If they do not have an effective response force able to get in to respond to the risk that this structure proposes, then they should be able to require a higher level of construction, such as residential sprinklers throughout the property, which would have given the additional time frame potentially needed to have either suppressed or contained the fire until the fire services, or at least to be able to assist in evacuation. So it goes to the whole piece of in that the fire services, and I'm a strong proponent for residential sprinklers is another hat that I wear. But it seems to be that we need to be pushing the municipality understanding and the fire services being involved in the review and pushing and understanding what their capabilities are with an effective response force, their training, education, and what they can actually do in a reasonable time. And yes, a property like that in hindsight should have been sprinklered throughout. And I'm also a strong proponent that public housing projects, for various reasons, should all be sprinklered because of, one, the nature of the individuals that we put in there are usually a disproportionate number of aged or having mobility impairments, but also because of the value of that housing stock. It's very limited. If we lose it in a fire, we usually lose multiple blocks. If they're sprinklered, we save the residents, but we also save those valuable resources. They're critical infrastructure in many of our communities.
Yeah, no, in terms of business continuity, that makes sense to me. It's interesting. I understand that you're keen on sprinklers. That makes some sense to me from fires inside the building. I think what I find interesting is that by all accounts at Beachmere in Crewe, that was actually hot works on a balcony.
Yep.
So actually, even if it had been sprinklered, that wouldn't have done anything. And there are other, there was one in Hounslow in Bennett Close. That was a cigarette that was discarded at the front entrance and set fire to some shrubbery, and that burnt through a plastic air brick, and then it was into the structure. And again, sprinklers internally are not gonna, help that, because actually the plasterboard is gonna keep the sprinklers from the fire that is now inside the structure. So I think it's half the solution.
Yeah, it is. You're absolutely correct. And we've had some spectacular fires here in the city of Ottawa as well, where we've had the exterior of the buildings go up and it gets up into the roof. And yes, major losses, even, and sprinklers would not have addressed those issues or challenges. Yes.
No. And I think Manthorpe Avenue, actually, up in Manchester, was another one that was the condensate pipe. The plumber was turning that into a C shape and from the outside of the building, and caught the structure on fire. And again, if sprinklers had been in there, that wouldn't have. Yeah, so I think it solves half the problems. Salish has given an interesting question, so thank you for that. you know, obviously in Canada, you sprinkler a lot more than we do. At the moment, we're only down to, now then, 11 meters. So anything below 11 meters to the top floor, and we won't sprinkler that. And that's only recently. Until recently, we were 30 meters and above, we would sprinkler for residential developments. But Sailesh asked about water mist instead of sprinklers. I mean, how do you feel about that? Because obviously that's even less water than sprinklers, and you know, you've got an awful lot of fire loading there.
Yes, good point. Right now, in order to go from their typical 4-story to 6 in Canada for the mid-rise, they would have been required to be sprinklered. And the encapsulated mass timber would also be required to be sprinklered to NFPA 13 as the standard. So that addresses some of the issues concerns. So now, with regards to again, there's the reliability of the systems. Usually, they're very reliable. The reports are showing that. Do I have concerns from the fire services with regards to those? No, I think that the benefits far outweigh. And before you get to the issue or a point where the water is going to cause that degree of significant damage, you got to remember that it's only going to be 1 or 2 heads potentially flowing in the fire compartment to either suppress or contain the fire. The fire services, before it ideally gets to a stage where it's that damaging, will be able to turn the valves to turn off the fire sprinkler system. So it would not be to that level of issues. As far as fire mist systems go, I'm aware of it with regards to mechanical space activations, special applications. The National Research Council of Canada has done quite a bit of research into that. Even looking at foam suppression systems in Canada as well for our northern areas where water issues are concerned. But I don't believe that the technology has advanced enough for these larger residential applications, and that it could be supported by industry and the property ownership. It still seems to be confined, in my view, to a lot of special applications at this particular point in time. So we don't see water mist breaking a lot of ground, probably because of the initial cost to install, the maintenance, and other concerns. So I think that's just where it stands. And a good point from one of the points from one of the chat comments is that some of our jurisdictions in Canada have required, and we would strongly be supporting, that we sprinkler exterior balconies. So you can have a dry head sprinkler that would extend through the wall to protect the sprinkler, the balcony, and the underside of the balconies. As well as you can use those in garage areas as well for residential structures. So that is technology is being pushed.
Okay, and we don't tend, if we do sprinkler, we don't tend to sprinkler loft voids either. So you know, if it gets into the structure, then the place it goes is up into the roof, and actually, you know, that seems like if we're going to sprinkler in the loft void, seems like a good idea to me.
Yeah, under 13, NFPA 13, which is the more heavier standard, it would cover void spaces, loft voids, as you would call them, a lot of the crawl spaces and other void spaces would be sprinklered. But the requirements go up with usually the number and heights of the stories of the buildings.
I mean, in terms of, I'm sure we've got quite a lot of fire risk assessors on the webinar today, and in terms of, you know, them and having to you know, carry out a fire risk assessment on a building and perhaps have no information when they arrive there, you know, how might they be able to identify a timber construction? Because you know, often obviously in a lightweight timber frame, the frame is going to be plasterboarded, but you know, CLT may be exposed, but at the moment it's more likely to be encapsulated by that plasterboard. So how could they perhaps spot, you know, I've got a timber frame construction here, and I need to consider this as you know, as potentially, you know, I've got some extra questions. This is a combustible structure.
Well, that's a very good point. From a Canadian perspective, I'd be turning around and advising them that from what we've seen for the construction is that anything under 6 stories, for the most part, you would pretty well assume would have been built from timber frame in the last few years, just because of the cost effectiveness or how cheap it is for them to build. There might be queues in and around any of the void spaces or such. I can't begin to say. In Canada, we would make more of this assumption that it was assumed that it was a combustible construction building, unless they were able to see the as-built drawings or have the building owner produce some as-built drawings and had detailed information otherwise. Yeah, that's a huge challenge. But I haven't followed sort of the history of the UK construction.
I think from my perspective and my experience is that generally you can open a service cupboard and stare up, and you'll probably see the timber structure.
Yes.
It's highly unlikely that it's been adequately plasterboarded, and it's a bit of a giveaway in the service cupboards.
Yes.
That tends to be my my go-to place. I mean, can we just finish up?
Anywhere you can see the voids.
Yeah, exactly. I suppose in the areas sort of, you know, that are out of sight and out of mind, you know, the more visible areas that everybody sees every day tend to be plasterboarded really nicely, just for the aesthetic finish. But actually, the plasterboard is there for a very different reason. And you know, once you get to the sort of the areas that people don't see all the time, that's a bit more telling, and you can actually see where things haven't been plasterboarded. You can actually get in and see what the structure looks like. Perhaps we can just close by having a quick chat about, you know, construction sites, because you know, we've had a couple of fires on construction sites. The one that I remember was Peckham in 2009, and you know, that site, I think it's fair to say, wasn't terribly well planned, and there was an awful lot of timber structures up at the same time that weren't clad, and therefore, you know, that it was a large fire, actually affecting, you know, sort of neighbouring homes and stuff to the site. You know, what's your view on sort of construction sites and things? Because obviously at that point the timber is exposed and it's not covered in any way.
Yes. We've been trying to bring the National Fire Code along for changes, and we looked at benchmarking to what was done in the IFE, the NFPA Fire Code, but as well I looked at we looked at some of the UK guidance documents that were produced with regards to construction site safety, because you too had some of these spectacular fires. And in Canada, we've had several spectacular fires. One that even made the national news, where we had a crane operator had to be helicopter lifted from above the burning building. It was his funeral pyre. He had to be hoisted from a search and rescue helicopter from above the building because of just how quickly and fast these buildings go. And the stick frame versions are just a nightmare. Now, encapsulated mass timber, what's unique about them is that they are purporting that they will be building a lot of these elements and assemblies off-site and bringing them in. So there's going to be very little construction debris on those properties. So there's I'm less fearful of those properties. But when it comes time to the construction site safety on the other buildings, I think it's a matter, again, is the fire services needs to have tools to be able to enforce. They need to have standards, something in the fire code ideally, but they also, suppression personnel who have the most to lose by this, really should be going out pre-planning and inspecting these properties and directing clearances so that there is indeed proper housekeeping procedures being followed, that there are indeed limited combustibles being stored. If possible, that fire stopping or sheetrocks are installed between larger elements to stop the major spread. That hot work is properly done, inspected. The individuals that are doing it have the training. They've been briefed. They have the extinguishers on hand. That there's a fire watch maintained in those cases. That there is site security, video surveillance, security of screens. Because again, arson fire is a major concern for us on those properties. There's a lot of examples, but I think the fire services need to be actually going out, inspecting, driving to the sites, inspecting, engaging with the contractors, and making sure they express their views of what their expectations are for construction site safety or fire safety.
Okay, I mean, I suspect that in this country we're quite a long way away from that.
So are we. So are we.
We do have the Structural Timber Association's 16 steps to fire safety, which I think is
Right.
is probably something that you've
I have seen it. Yes. Yeah.
yeah. So that can be quite a useful guide. Okay, I mean, the things that I've taken from this is kind of, you know, I can hear a colleague and he'll know who he is when he says challenge everything and assume nothing, you know, and I think it's
That's
really
fair.
easy.
I like that.
Yeah, it's really easy, isn't it, to think that it will all be okay, but I do like your idea of the placards on the buildings. Yeah, I have to say, although I think they would end up being badges in perhaps teenage bedrooms. And I do have concerns, like you said, about, you know, where we've got vulnerable and the colleague has just thanked me. Excellent. I do have concerns about, you know, where we've got vulnerable people in these timber frame construction because obviously, you know, they're going to take longer to exit the building whenever they're told. So I share your concerns on that. Well, look, Sean, I'm going to round off tonight's webinar. I would like to thank you once again for giving us tonight's presentation and sharing your knowledge with us. Totally understand your technical problems, so thank you for working so hard to sort those out. We really appreciate you coming, you making every effort to come and get here. That's great. Yes, Russ, fire marks. I totally agree. I understand where you're coming from. I'd like to thank TechFire for providing the IT to do this. And I would also just like to say that the Southern branch is going to be running these webinars every first Wednesday of the month, and the June one is the next one. Obviously, that'll be on the 2nd of June, and the topic's going to be building safety cases. So what does a building safety case actually look like? And we're going to have 2 early adopters who've actually been writing those to come and talk to us and explain to us, you know, what those documents will be looking like for all of us going forward. We'll have a link to register for that on the IFB website next week, and in a minute I'll put it in the meeting chat. But for now, thank you everyone for attending. Thank you for bearing with us, and good night.